Let's discuss any concept now. We have to find out the position of the roots. If first condition is condition for a number k to lie between the roots of the quadratic equation. That means if a number k, real number k, lies between the roots of the quadratic equation, okay, then what will be the condition? First check, let's assume that quadratic equation is ax square bx plus c, okay. We check for the k, what is the condition. So let's suppose first a greater than 0, okay, and for the real roots we are dealing with the real roots only, and for d greater than 0, and what will be the graph for a greater than 0 and d greater than 0. Graph is somewhere alpha beta is roots, given also number k lies between the root. K is somewhere here, okay, then fk is here. From the graph here a is greater than 0, then we can write a fk greater than 0. We go to conditions. If a greater than 0, then d greater than 0, as well as a fk greater than 0. Again, if we see a less than 0 and d greater than 0, then what will be the graph? Graph will be such that alpha beta and fk somewhere at a point k. Here a less than 0, then what will be the sign of afk? A less than 0, fk greater than 0, then it will be less than 0. Okay, I made a mistake here. This is less than 0 because fk is less than a positive. Then from this, from both combining both first and second, what we get? We get d greater than 0 and afk less than 0. If the number k lies between roots a and b, roots alpha beta, then what will be the condition? We have to check the condition. First, discriminant is greater than 0 and afk should be less than 0. Okay. Now let's discuss question based on it. Okay, let's discuss the question based on whatever we studied yet. Find all the values of the a so that the 6 lies between the roots of the equation x square plus 2a minus 3a and 2x plus 9. We have to find the value of a. What is the possible value of a such that 6 lies between the roots of equation? Suppose alpha beta are the roots. Okay, are the roots. We have earlier studied that fx x square plus 2 a minus 3 x plus 9 equals to 0. Here first here there are the two roots, then d greater than 0. Okay, also here a, compare with the expression ax square plus bx plus c, then a is positive, hence afk should less than 0. Okay, here k is 6. Compare with this graph, k lies somewhere this and fk is this, a positive 1, then 1 dot fk, 1 dot f is f at value 6. Okay, this expression is assumed at fx less than 0. Okay, f6, substitute the value of 6 in the expression fx. What will we get? 36 plus 2 a minus 3, 6 plus 9. Okay, 3 can be taken out, or we can solve it. 3 can be taken out, then what will be that? 12, 12, 3. Okay, then we can further simplify h. 12a plus 9 less than 0. Okay, from this we can write a is less than minus 3 by 4. Okay, from this condition obtained from AFK is less than 0, then we'll look for D greater than 0. What is D? Discriminant b square minus 4ac minus 4ac greater than 0. B is here, b square 4 a minus 3 whole square minus 4 ac is a is 1 and 9. That should be greater than 0. 4 can be taken out. A minus 3 whole square minus 3 square. Okay, we can simplify that a minus 3 and a minus 3 plus 3. Okay, a minus 6 and a we can assume it is 0. That should be greater than 0. Okay, draw on the a line. Here we assume 0, here we assume 6. First check the values of a on this number line. If we substitute the value greater than 6, then that will be positive. That is positive. That will be positive. Here positive. And between them, suppose 5. That is negative. That is positive. That is negative. That is positive. Sorry. Okay. We want the value of a such that this expression is positive. Positive is somewhere. That means minus infinity to 0 union 6 to infinity. We will not include this endpoint 0 and 6 because here this will become 0. We are not taking that in account. This is the second condition. Okay, and from first, what is first? A is somewhere less than minus 3 by 4. Minus 3 by 4 is exist here. Okay, A is less than minus 3 by 4. Then combining first and second both, then what we can write? We can shift 0 here, minus 3 by 4. Okay, we want to take common of that. It should be this. We will not take this portion, only a common portion of both of these conditions, that will be below minus 3 by 4. What will be the minus infinity to minus 3 by 4. Okay, that is our answer. I hope you understand this. Thank you. Okay, now we want to obtain the condition for which for both the roots of quadratic equation to be lie between the numbers given in K2. If suppose alpha beta are the roots, okay, and both roots are lies between K1 and K2, what will be the condition? First check if a greater than 0, what will be the graph? A greater than 0, or we consider only d greater than 0. Then if a greater than 0, alpha beta are the roots of the equation to be lie between the number of Q1 and Q2. We are assuming here, then both the roots is lie between Q1 and K2. Then K1 is suppose here and K2 be suppose here. Then A is positive. Then A is positive. Then AFK1 is will be positive, and from here it is also positive. Then AFK2 is also positive. D is greater than 0. One condition is that this is what is this value? This value minus b by 2a. That is the value minimum at this point. From this graph we can say minus b by 2a lies between K1 and K2. This is obtained when a is greater than 0. Then when a is less than 0, what will be obtained? Graph will be somewhere. Okay, here k1, here k2, here alpha, here beta minus b by 2a. From this value of k1, f k1, that is negative, then and also a is negative, then a f k1 will be positive, because a negative, then f k1 it is also negative. Here also a f k2 is positive, again minus b by 2 lies between k1 and k2. Commenting on the condition for irrespective of a positive or negative, we can write d greater than 0 first, second, af k1 greater than 0, af k2 greater than 0 also, third, k1 is less than minus b by 2, a less than k2. Okay, we have to go through all three conditions. Let's discuss one question based on it.